Okay, so just a little background. At best, I would say that I am a novice at photography, but how this all started was I had children, and then you have to get all those pictures taken, and you're like, oh my gosh, this is really expensive to get, 3-month pictures, 6-month pictures, all this money that you're spending. And I was like, oh, you know what would be cheaper is if I bought a nice camera and I learned how to take photos. Well, long story short, photography is a very expensive hobby, so I'm not sure that I actually saved myself any money, but I did learn a lot of really cool things. And the more I started learning, because I didn't want to just buy a camera and just use, the regular settings and have the camera decide the exposure and things like that for me, I wanted to learn how to shoot in manual mode, so where I control everything that the camera basically does. So I started taking classes and learning about composition and exposure, and the more I got into it, I was like, there's really actually quite a bit of math that dictates what happens when you're taking a picture. So that's kind of how this was inspired. So in here I've used photographs that are much better than mine, but also I've sprinkled in a few of photographs I've taken of my children. So the first part, I'm going to talk about two things: exposure and composition. And so there's 3 things that go into the exposure of a photograph. And we're going to talk about each one. So there's shutter speed, aperture, and what we call ISO. Okay? And so all of these affect each other. So if I change my shutter speed, that's going to affect my exposure. If I only change my shutter speed but I leave aperture and ISO alone, that's going to affect my exposure. If I change ISO but I leave the other 2, now suddenly I might have an under or overexposed photo. So a lot of times you can't just change one without adjusting the other. So from a photography standpoint, you have to kind of decide, what is my main goal here? Do I want to, we'll look at this, freeze the action? Is that kind of my main goal? Do I want a really nice blurred background where I can only see, the person's face and everything behind it is blurry? So you kind of have to make those decisions when you're deciding how to change all 3 of these. So exposure. And we'll look at a histogram of exposure in just a moment. But basically, when we're talking about exposure, we're talking about the brightness of the photo. So we can have things that are underexposed, and we'll talk about how that means sometimes you can't recover a lot of things in Photoshop or Lightroom. So if you underexpose your photo too much and you try to just bring the exposure up after you've taken the photo, then it's going to not look as good. But there's times when people want a decreased exposure. They're going for like a darker look to their photo. And so in a camera, you can actually see these settings. So as you're taking the photo, you can tell if it's perfectly exposed according to the histogram. And we'll talk about that in a minute, if it's overexposed or underexposed. So this is what the histogram looks like. So you can see this on, if you have a nice digital camera, it will show you the histogram of the photo. And so you can look at that and tell the exposure. Also, if you use photo editing software, the first thing that comes up kind of in the corner is the histogram of the photo. So this is what we would generally call like a perfectly exposed photo. And again, there's times we want this histogram to be shifted more to one side or the other. But these are the components that it's measuring. How much of your photograph is white, pure white, versus how much is black. And then there's shadows, midtones, and highlights. And all of these can be adjusted, which is going to shift the histogram slightly. And it's going to change the exposure, but it's also going to change the look of the photo. So for instance, if I were to move this histogram this way, the blacks in my photo would become, I guess I would say, even blacker. So they would stick out more. There would be more contrast in the blacks. So that's just kind of like a standard histogram. So if you open your Photoshop or your Adobe Lightroom or whatever, if it's all the way over here where the majority is in the blacks and you have lots of shadows, very few midtones, then your photo is really underexposed, which means if I try to just, do the little slider where I bring up the exposure, my photo isn't going to look very good at all. Okay, I'm going to have, it's going to have what we call noise, or it's going to be really grainy. Here we have one that's exposed to the left, so not as grainy. We can recover a lot of detail in Photoshop or Lightroom, but it's not going to be as good as if we can get a nice neutral exposure. And the same thing kind of going the other way. If it's overexposed, it means my photo is really, really bright. And in order for me to bring it down, I'm going to have a hard time recovering a lot of detail in this photo. So again, you can set your camera so you can actually see that while you're taking the photos, or you can just look at what was on the other photograph, like the +1, +2, either way, and try to get it right in the middle. But again, there's times when people purposely underexpose and overexpose just for an artistic look to the photos. So the first component is shutter speed, and this is really just how long the shutter on the camera is open for. So the longer that it's open, the more light is going to be let in, and the shorter amount of time that it's open, the less light that's going to be let in. So these are measured in fractions of a second. So for instance, 1/250 means it's open for 1/250th of a second, so really quick. And actually they can be a lot faster than this, which is really only 4 milliseconds. So there's things that can happen when we start changing this shutter speed, and there's reasons why we might want something like 1/250, or we might, I'm having a hard time talking, might want something that's longer, and I'm going to show you examples of that. So like I said, the longer it's open, the more light is exposed. This not only affects the brightness of the photo, but what we call motion blur. So for instance, with my children, if they're outside playing, especially if they're playing sports, which they do a lot of the times, and I want to get photos of them taking or playing soccer or playing football, even what we talked about a second ago, 4 milliseconds is too long for that shutter to be open. I'm still going to get some motion blur. So a lot of times my shutter speed might be way up to like 1/1000. So 1/1000th of a second. So I can freeze that action. So a fast shutter speed will freeze the motion, and we'll look at some examples of that, while a slow shutter speed will blur the motion. So here are some common, this is supposed to, I guess, be a person running. The longer the camera is open, the more motion blur. And so here's 1/250. Obviously in this you can't see the difference, but at 1/60th of a second, most people use a tripod, because just holding the camera with your hands, the little bit of camera shake that you can get from trying to hold it still can blur your photo. Once you get up into these faster shutter speeds, you don't have that problem, so it's fine for you to just hold your camera by yourself. But usually around this time, people start using a tripod, because it's open long enough that even if your hand moves a little, it's going to blur your photo. Okay, so why would we want to blur motion? Like, why would you want a blurry photo? Well, here, if you look at the waterfall, the rocks are obviously not moving, but the water is, so it's blurring the movement of that water to look like a nice cascade. Whereas if you increase that shutter speed, it's going to freeze each little drop of water there. So that's one place where we might want a slow shutter speed. This is done with a slow shutter speed, but also panning the camera. So if I had just held the camera and left it open, he would have been blurry too. But by moving the camera as I took the photo, I was able to keep him nice and sharp while blurring everything around him. And then if you can tell by the words on here, I flipped the photo, so those are backwards. You would be able to read them, but I flipped it because my neighbor's house was over here and it looked better going this way. But that's just more aesthetically pleasing. So again, here's another example of when we might want to blur motion. This is a good example that I couldn't get with my camera, although I tried with fireworks on the 4th of July. So if you leave that shutter open longer, then you're going to see the entire firework as it's moving out versus freezing it in time, like here. So that's another reason why fireworks, things like this, we might want to blur motion. So like I said, fast shutter speed when people are playing sports. Even to just take a picture of my children sitting still, because they obviously don't sit still, I would use a faster shutter speed so that I can freeze that. But here's just, this is 1/15 of a second, 1/60th, 1/125, and 1/500. So the faster that shutter speed is, the more you're going to be able to freeze that motion. So here's some frozen bubbles that he was blowing. And then this is after a mud run, so he was getting hosed off. So you can see, it's kind of hard because it's kind of bright in here, but the water droplets are frozen, so that's a faster shutter speed. And then there's another really good example. I didn't do this one, that would be cool, but. Okay, so our shutter speeds on a camera, so you can't just pick any shutter speed that you want. There's select ones that are given to you. And they are a geometric progression starting at 1 with a multiplying factor of 1/2, except for 2 places. And there's a reason. So if we had just kept multiplying by 1/2, then we would be at 1/16, 1/32, and so on. So once they got here, so that we had numbers that ended in 0 or 5, then they changed it. So then we had 30 and 60. And also because we have 1/60th of a second. And then also here is a slight variance from that geometric progression, so that when we start multiplying these by 1/2 every time, we get these nice even numbers. Yeah?
Does it mean that they are not exact then? Is there any compensation anywhere in the process? Because if you stop at 8, you would be at 16.
No, so it doesn't affect, they're not exact. They just, instead of to keep going up by 16, 32, 64, etc. All of those numbers wouldn't have been like these nice numbers that end in 0 or 5.
So what you're saying is those are the actual shutter speeds, they just don't happen to follow what mathematicians would have preferred.
Exactly.
Since hertz or like cycles per second 60 is pretty typical.
Right, exactly. Yes. But no, these are what you would actually see on most cameras. And again, it's going to depend on the quality of the camera. So some of them might not have a shutter that stays open for 1 second. Some of them will. Some of them will actually the shutter can stay open for longer than a second. And so that would give you a really long exposure, but it's going to depend. But these ones right here, even going up to 1/500, these are pretty common on even just like your point and shoot cameras if you're able to adjust those settings. Okay, so after that we have what's called aperture. So aperture refers to the circular opening in which the camera's lens that dictates how much light is available for the image. So not how long the shutter's open, but basically how big the circle's going to be that is going to let the light in onto the photo. Okay? So this kind of works similar to the pupil of your eye. If it's really bright out, your pupils are really small. So if we are shooting outside on a bright sunny day, we want that opening in our lens to be really small to not let as much light in. And if you're in the dark, you want your pupils are going to be open really big to let more light in, and that's the same way that a camera works. So this is an example here. So you'll see how this is a little counterintuitive based on the numbers assigned to our aperture, but a small aperture means we have a very small opening to let light in. So again, this would be a bright sunny day. And a larger aperture means that opening is open really wide, so we can let a lot of light in. So this is often referred to as the f-stop, and so even on cameras, you might have f2, f5.4, and that's referring to the aperture. So small f-stop numbers, like f1.4, actually refer to a large aperture. So if you have an f-stop of 1.4, it means the camera lens is very wide open to let in light. If you have a small aperture, like f22, which is a big number to us, that's a really small opening, not letting in as much light. So while the values that they've assigned to the f-stop are related to the diameter of that circular opening, the amount of light let in is actually related to the area of that circle that's open. So the values assigned are in relation to the diameter, while the amount of light is actually related to the area of the circle. So here are some, and I wouldn't say really common ones. So if you were to just go out and spend, like $300 on a camera, it might have a lowest aperture of 5.6 or something around there. Lenses like this that have these larger apertures are generally much more expensive. And most cameras, like this diagram only goes up to f11, but I'll show you one that I shot at f22, so a very small opening. But again, large aperture, small f-stop, small aperture, large f-stop. Okay, so not only does this affect the amount of light, which affects our exposure, but the main reason we care about aperture is it also affects the field of depth on a photograph. So how much of your subject and the area behind it is in focus. So if I were to shoot at f1.4, I would have a very narrow field of depth. So even just taking, if I were to take a picture of Song at f1.4, depending on where I am, I might only get his nose and part of his eyes in focus while his ears could be out of focus. So I have a very narrow field of depth, again, depending on how close or how far away I am. If I'm shooting at f22, so a larger f-stop but a smaller aperture, everything's going to be in focus. So not only, if I shot at f22, not only would I be able to see Song very clearly, but I'd be able to see Jen very clearly as well, and the wall behind her, okay? So that's the main reason photographers care about aperture. So here's an example. This is a large aperture. Again, this would be a small f-stop though. So you can see how really even this flower is kind of blurred. Whereas if we get a small aperture, but again, a large f-stop, then we have a lot more depth of field. We can see the grass behind it. All of the flowers are in view. So another thing that photographers use this for is to create what is called bokeh. So these are just Christmas lights. This is shot at f1.2, 1.8, and then 2.8. So we have a smaller depth of field, which is also blurring the Christmas lights. So those are actually just Christmas lights behind there. It's blurring it more as your f-stop gets smaller, but your aperture gets larger. So we only have a very narrow field of depth. Okay, so why would we want to use a really large aperture then? Well, here's an example. If I had shot this at, like, say, f2, all of this would be blurred, including the sun. By using a very large aperture, so I can clearly see everything behind him, but it also creates this sunburst here. So in order to create that, I had to use a very large aperture. But everything behind him, the grass, the trees, the road, everything is in clear view. Okay, so where do we get these f-stop values from? Hold on, I gotta take a drink. Okay, so there are lenses that have smaller apertures, but for a lot of photographers, 1.4 is kind of the lowest that we want to go. So again, this is a geometric sequence, but this time we're using a ratio of 1.4 with some rounding. So again, so we don't have all these decimal numbers on the camera, they're going to round. So each time we're taking this f-stop and we're multiplying it by 1.4. So our next one would be 2 because we rounded up from 1.96. Our next one after that would be 2.8. And then f4, which is rounded again to give a nice number. And then 5.6 and so on from there. So every single f-stop value to get the next one is multiplied by 1.4. Okay? But why? Okay, so with every change in f-stop, the area of that circular opening is doubled. So each time we go up from, let's say, 1.4 to 2, we're doubling the area of the circle, okay? But when we're going, so from a large aperture down, then we're cutting it in half. Okay, so we're going to talk about it to figure out why we use 1.4. We're going to talk about it as if we were going from a small aperture to a larger one. So when we cut that f-stop, or when that area is cut in half, so is the amount of light. So going the other way, then it's going to double. Okay, so here's a good example. Going from f8 to f5.6, the area of these circular openings are doubling each time. And that's going to make the most sense in figuring out why in the world are we multiplying by 1.4 instead of just doubling like we did before with shutter speed. Why aren't we just multiplying everything by 2 each time? Because remember, the f-stop values are related to the diameter of the circle. Okay, not the area. So in order to change this f-stop value, in order to change that diameter each time, we have to affect the radius of the circle, okay? Because that is directly related to the diameter. So how do we change the radius in order to double the area each time? Okay, so here's one circle where we're starting. Area is pi r squared. Here's our radius. We want to figure out our new radius so that the area of this circle is twice as much. So I want twice the area, and I'm going to use x to figure out what that radius is. So just using substitution, I'm going to replace where I had 2 area, I'm going to replace that with just pi r squared. So just using substitution, if we divide both sides by pi, then we get twice the radius squared is equal to this new radius that I want of x. And so if I square root both sides, what we're really multiplying the area by each time is the square root of 2, which if you round that to 1 decimal place is 1.4. So if you want to change the radius so that the area of a circle is doubled, you just need to multiply it by the square root of 2, and then that will double the area of the circle. So this is where we get the 1.4. Yeah.
Why does it go the opposite way?
What?
Why are you dividing by 1.4 instead of multiplying by 1.4 for the f-stops? So it's smaller, like to get double the area, I should be multiplying by 1.4, but 1.4 was the biggest area.
Right. So
I'm actually dividing by 1.4.
that is I thought about including that, but that is like a long explanation because I know what you're saying. Like it mathematically, it doesn't, or just in a sequence, it doesn't make sense. But if you go, let me see, hold on, let me go back. I want to show you. Even the f-stop values are kind of counterintuitive. So if we're saying that it's in relation to the diameter of the circle, then we would assume this f-stop would be larger than this one right here. So even these f-stops are kind of counterintuitive, but again, that is a long explanation.
History behind that slash?
No. The grammar behind it?
No, I meant it, because if you do f divided by 1.4, then it would make sense.
Oh.
If that really meant some
Oh.
focal length
Yeah, yes.
divided by the area.
No,
then
exactly.
that would make sense.
Yes, and that's what I was going to talk about, but so this is just kind of a very basic understanding of aperture. When they're actually computing aperture, they are taking the focal length and including that in the calculation for the f-stop, okay? So a 28 millimeter lens is going to be different than a 50 millimeter lens and so on. But again, just for brevity, I'm just talking about like the most basic explanation here. Does that make sense? Okay, hold on, let me go back to where I was. Okay. So the last thing is ISO, which actually stands for International Standards Organization. But what this refers to is how sensitive the internal sensor is to light. So the higher the ISO, the more sensitive it is to light, and the lower the number, the less sensitive it is to light. So, for example, if I were shooting out in bright sunlight, I would have a really low ISO. I would shoot at probably 100, again, depending on my shutter speed and the f-stop that I'm shooting at. If it were really dark, like if I'm shooting inside my house in the winter, I would use 6400. That's going to make my camera much more sensitive to light. So this is adjusted when we need to let in more or less light, but we don't want to compromise shutter speed or aperture. So maybe I need to shoot quickly because I'm taking a picture of my kids opening Christmas presents, but I'm inside my house in the winter and it's really dark out, so I might change my ISO instead of changing my shutter speed and leaving that shutter open longer. And maybe my house is really messy and I want to blur that background, so I don't want to change my f-stop because I don't want people to see how messy my house is. So this is when we might change our ISO. So here are just some examples. So I can, just by simply changing the image, the ISO, I can go from having a very dark, underexposed photo to a well-exposed photo. Just by changing that one thing, keeping my f-stop the same, my aperture the same, and my shutter speed the same. Also, how high you can go up in your ISO is going to depend on your camera. So the really nice, like full-frame, expensive cameras that professionals shoot with, their ISOs go up really high, whereas if you were just to buy like the base model, it would probably only go up to 3,200 or 6,400. So what this will also do, however, is make your photo grainy if you have a very high ISO. So everything isn't going to be perfectly crisp and clear. You're going to have grain in your photo as you increase this. So sometimes it's a decision you have to make. Do I care if it's grainy because I want these two other things to happen, or do I not care? It can be grainy. Okay. So the grain is also called noise in an image. So the first one is shot with an ISO of 100, so we would call that a clean image. The second one is noisy because it has all that grain in it. But again, if this were really low light and you didn't have a choice, you might just have to deal with it. Okay, so this is again a geometric progression, usually starting around 1 or 200, again depending on your camera, and this time we have just a geometric factor of 2, so it's being doubled each time. This one doesn't have any changes. We just double it each time. And again, these can go higher. Okay, so next one, composition. So we're going to talk about some different rules of composition and why, generally speaking, this photo is more aesthetically pleasing than the first one. Okay, so composition is, I gotta get this hooked back on. The makeup of the photo, so we're talking about the placement and the proportion of the different things in the image. And just because of how the human eye is, some of these are more aesthetically, visually pleasing to us than others. I will say, John Dersch, had I been able to find a photo of you, you would have been in this PowerPoint.
I'm grateful for your inability.
So also, part of why we care about composition is we are trying to give a three-dimensional sense to something that's only two-dimensional. So we have to use the elements in the photograph to create that sense of the third dimension that isn't actually in the photograph. So the first one is the rule of thirds, and we're going to talk about another rule that is very similar to this. So this is where the photograph is divided into 9 equal rectangles, just with a 1:1:1 ratio. And generally speaking, we'll see this in the next one, what photographers try to do is place an important part of the image along any of these intersections right here. So in this case, this is kind of your main focal point, so it's purposely placed along that intersection. And again, all these rules are made to be broken, but a lot of times, if you're going to use 2/3, we either try to use the upper 2/3 or the lower 2/3, so we wouldn't want to take this whole, both of these, this part here up with the rocks. So you can use 1/3 of it, you can use 2/3 of it, but we generally just don't use the whole thing. So like I was saying, the most important elements, which it's hard to see their faces, are placed along those grid lines. So in this case, it's her eyes that are placed right around these grid lines. So even if you took just a portrait of someone's face to give it a more interesting composition, instead of just putting them like smack dab in the middle, you might place even just their left eye along one of those grid lines, and it would give you a better composition. So this one is lined up in the middle, and this one would be along his face right there, would be along that upper 2/3 grid line right there. So not a huge difference, but a little more aesthetically pleasing than just centered in the photo. So the next one, the phi grid, it looks a lot like the rule of thirds, except now we're using a 1 to about 0.618 to 1 ratio. So you can see that these black lines right here would be the phi grid. These middle lines here are smaller. And so this, again, looks like rule of thirds, but we generally use the phi grid when we're doing landscape photography, when we want to include the landscape in the image versus just a portrait. So this is one kind of very simple variation. We're going to talk about this a little more in just a minute, but here's another one. So one thing also photographers try to do is they try to place the horizon either along this upper 2/3 line or this lower 2/3 line. So we wouldn't try to put our horizon like smack dab in the middle of the photo. So in this one you can see this horizon line is placed along the lower 2/3, whereas the last one, it was along the upper 2/3. And again, that makes it more visually pleasing for us. Also, it helps you make sure that your horizon line is straight so that your photo isn't, going like that. It's helpful. Okay, so this also relates to what we call the golden ratio in photography. So we'll talk about this a little more. So this has a bunch of different names, again, depending on who is talking about it. So it's often called the golden ratio. Sometimes this is called the phi spiral. It just depends. So where do we get this from? So the golden ratio says that the ratio of A to B is equal to the ratio of A plus B over A. And we'll talk about how this comes out to be phi in a moment. But we're using, in order to get those values, so our first ratio would end up being 1/1, which is 1, and then 2/1. And so as we continue, and you'll notice we'll talk about these numbers over here in a minute, eventually we get to, by dividing those, we get to phi, which is, when we talk about it here, we're just going to say 1.68. So those numerator values are the Fibonacci sequence. So where we get the next number by taking the sum of the previous two numbers. So 1 + 1 is 2, 1 + 2 is 3, and so on. So that's our A plus B right here divided by A. Okay, so what does this have to do with photography and composing a photo? Well, if you look at that grid, and it's hard to see here, the spiral is shaped around these different size rectangles, and these are actually those values we were just talking about. So 1, 1, 2, 3, 5, 8, 13, 21, 34, and we can make this bigger and bigger. So this would be a 34 by 34 rectangle, and so on. So we're actually using those numbers from the Fibonacci sequence to make these different size rectangles. And so the idea is to proportion your photo, which is mostly done in editing software. You can get a good idea of this. Also, some cameras, you can have this as an overlay as you're shooting, which is helpful. Or a lot of times people will just go into their editing software. We have all these different grids that we talked about, so you can pull up the grid for the rule of thirds and have that overlay your photo, so then you can crop your photo to fit it. So you could overlay this spiral onto your photo and then crop your photo and adjust it so that it fits that spiral. So here's just an example of the two that we talked about. So this one is cropped using the rule of thirds. So our main image, or our main focal point, is along that intersection right there. Whereas here, when we include that phi spiral, we also see that it draws our eye out to this guy. Looks like he's also on a surfboard out here. But these images you can actually overlay in Photoshop as you're cropping. So depending on what kind of look you're going for. So 3 different compositions. Again, rule of thirds or the phi grid are similar. This would be a balanced photo, rule of thirds. And then just with a portrait, using the start of this spiral around the person's eye would be one way to compose this photo. So just some other things that are fun, but so they are mathematically related, but we don't have like complex formulas. We talked a lot about these different compositions where we don't necessarily want the person just centered in the photo because that gets boring after a while. But there are times when we do want something centered because it has symmetry. So here's another cool example of symmetry. Another one is negative space. So we have kind of a smaller image, and all around the image there's blank sky or something that's, what's the word I'm looking for? I don't want to say monochromatic, but I can't think of the word I want right now. So this picture right here uses negative space, so our subject is very small, but by using all this negative space, it makes the photo more dramatic, and it uses the rule of thirds, so this person would actually be centered on close to one of those grid lines right there. Here's another example of negative space along with the rule of thirds. So here's our subject. Everything around it looks very similar. And then the last one is leading lines. So what we're trying to do is use lines to draw the eye to what we want people to look at. So in this case, the railroad tracks are drawing your eye to the person way down at the end walking along the railroad tracks. And then this is another example of leading lines. So this is what railroad tracks are drawing your eye to the person way down at the end walking along the railroad tracks. And then this is another example of leading lines. So this is what we call giving a photograph movement. Because she's walking in the direction of these lines that we can see in the image, it makes us feel like we can see her walking, even though this is a frozen two-dimensional image. I think that's the last one. It is. Okay, so questions? Yes.
The mathematics of depth of field.
Of what?
Of depth of field.
Mm-hmm.
So when you change the lens because you want to use it to point A because you want to have a portrait. How much of the image, what the percentage of the image is in focus and what is blurry?
It just is it's gonna depend on the focal length. So if I'm using a 50 millimeter versus a 30 millimeter lens.
Yeah, but is there a formula that helps us figure out 200 millimeters, right? 200 millimeters far away, I'm going to be able to have a certain depth of field to point A.
Yeah, so.
But how do you calculate that, and how do you know where to position the subject?
So that's going to depend, again, on a lot of things. Hold on, let me see if I can, one of these markers over here works. So for that f-stop, we're using the focal length divided by that diameter, I believe, off the top of my head. And so again, changing this focal length is going to change the depth of field, not incredibly drastically. If you're just, say, going from like a 50 millimeter lens to a 75 millimeter lens, you might have a few more inches. But really, I would say that most photographers don't compute their field of depth. They just position their subject and then figure out based on just taking a photo. If I stand here, now I'm missing their ears. Their ears aren't in depth.
The reason why I asked this question is because when you're ready to buy a lens,
Yeah.
For me, it's all about food and people. So you may be taking a picture at a certain distance.
Yes.
And you want you want the depth of field that much on that photo because you want to make sure that everything on that plate is in focus.
Right. Yeah.
So that's why I was asking this question.
Right, and so that's also going to, okay, so remember also that your aperture can be changed. So the reason you might go out and let's say you just want a 50 millimeter lens because it's not going to be really heavy, and I don't want a 200 millimeter lens because I'm not shooting anything that's super far away. So with something that's like 200 millimeters, I might use that to take pictures of my son on the soccer field playing soccer because he's far away and I need to be able to zoom in. But if you're going to, if you just know, okay, I'm taking just food pictures, I have a choice of two 50 millimeter lenses. This one I can go down to f1.4, whereas this one is only f2.8. What this is going to do, so you might not even be able to shoot any of your food using this aperture with this lens. You might still, right, so you might have to use f2 on this one. So you might not even get to use that 1.4. However, this lens, because it has this capability, even if I shot these at exactly the same aperture, this would take a clearer, sharper picture than this one right here. Okay.
Yeah. Used to be when you buy the film, it has an ISO number on it.
Mm-hmm.
And then you match the ISO on your camera to go with that. Since we don't use films anymore, how do they use the ISO on the digital camera?
So again, it really when we use ISO a lot is low light. That's where we care, where we can change that ISO. Also, let's say I'm going outside to shoot pictures of my son's soccer game. And I know I want to, or maybe not even soccer, like maybe he's doing something where I have to use a slower shutter speed. Like maybe I'm taking a picture of a waterfall on a bright, beautiful day. And so I want to leave that shutter open longer so that I can get that nice blur on the water. So I don't want to change my shutter speed to leave that shutter open longer. So what I would have to do is use a really low ISO like 100 because that is going to make my camera much less sensitive to light. Okay, so what I might also have to do if I want to leave that camera lens open longer is I might also have to go up to f22 because now I have a really small opening in my camera lens. I can leave it open for longer to get that blur, and I can use this ISO because it's bright outside. And if I use that long shutter speed, it's going to let more light in, so I run the risk of overexposing my photo. Okay, so all three of these kind of affect one another, so you can't change one without compromising something on one of the other ones. Yeah.
So I'm thinking all those trips I took when I came back and look at our pictures and you say, that doesn't look like what we took because I didn't have the seminar before we went. It could be all that
Yeah, and so it's fun to shoot in manual mode and be able to adjust all these things. It's also stressful if you're like on a vacation and you have 5 minutes and you want to take a really good photo. So that's why, you know, like if I go on vacation with my kids, I might just let the camera decide for me. Or actually, cameras have different, what they call priorities. So say the only thing I care about is shutter speed. I can set my camera to say, I'm gonna pick the shutter speed, you camera, figure out the other two things. Or I only care about aperture, so you camera tell me what shutter speed, you figure that out. I know I want this aperture, you just go ahead and figure out the other two. So that's also another option to give you some control without having to make like a million decisions.
Just sounds to me like you gotta take another trip.
Yeah, that's, you don't get to ask a question, so.
May I ask a question?
I guess.
So the fee rule composition, that particular fee rule, did that exist only because photography became a thing and so it was developed for photography, or was it pre-existing, like for painting?
Yeah, no, for painting as well.
So that'd been around for a long time.
Yes.
Because of the golden ratio.
Yes.
I mean, I'm gonna be honest, I don't think I have an eye for photography at all, because when you say, well, this is more aesthetically pleasing than that, I look at it and go, you know? So it's interesting, really interesting to me as to how, so, you know, I get the mathematics, I'm familiar with the mathematics of the golden ratio and all that stuff and the history of it. It's the aesthetics of it that I find a little puzzling, in the sense of who decided this looks better than that?
Probably.
I don't know what you know.
Probably. I don't know who made that decision, but I do know that it's used all the time in art as well, in painting and drawing and things like that. So it's not just for photography.
Since it was around since ancient times, we just continue to use it for photography. And so when I take all my pictures, and the thing that I'm interested in is right in the center, basically what you're saying is that's wrong.
Well, no. I mean, if that's what you like, then that's what you like.
But it depends if it's a technical photography.
Right.
If it's for engineering or anything, you want it smack in the center because you want to be able to break it into pieces.
Exactly. It just depends. You know, if you're just taking vacation photos, like who cares? But if you're a photographer trying to get more movement into your photos and draw the person's eye somewhere like an artist would in a painting, then you might follow some of those rules. But the first thing they always say in photography classes is these are the rules, but break them all the time. So we like these rules, but feel free to break them because that might make your photograph more interesting as well.
Do you have any sense of, as technology is getting faster and more affordable, if the sort of, will there be more options on a camera or less options the computer's going to take over? Or do you think it'll be a blend because there's still an industry of people who want to make their own choices?
Yes, so I would say the last one both. So what is happening right now is, so until probably a few years ago, everyone was using DSLRs, which are very heavy. You can control all this stuff. You can get really great low light photos. But they're big cameras. They're heavy. The lenses that go on them are heavy. So what's happened in the last few years is mirrorless cameras have, they've been able to make much better mirrorless cameras. So it weighs a fraction and it takes just as good a photo. So you can have a smaller camera that doesn't weigh as much and you can get even better photos than you could on this huge clunky DSLR. But you're gonna pay a hefty price tag. But I feel like that's where this is shifting right now. I don't think that at any point in the next 10 years will you be able to get as good of a photo on your iPhone as you can using an actual camera. It's getting better, but I mean, if you've seen the portrait mode on your iPhone, it makes everybody look really weird. Like it just makes the photos look weird. What they're trying to do is affect the aperture in those photos, and they just don't have it right yet. I would say in the next 10 years, don't expect your phone, but expect to be able, for the price of those mirrorless cameras, to be able to go down where you can get really nice photos on a camera that doesn't weigh a ton.
And it's more affordable for the sort of average consumer.
Yeah, because right now, like a really nice mirrorless camera could easily cost you $6,000. Yeah, if you're a professional photographer and you don't want to carry around a big camera, but you want to have really great photos, it's going to cost you a lot of money. And that's just the camera, that's not the lenses or anything that comes with the camera. So.
That's another 6,000.
Yeah, right. Yeah, the lenses sometimes can be more than the camera itself, so. Any other questions? Okay.
Andrea, thank you very much.
Thank you.